Hello Year 11 and welcome to our fourth and final video here for coordinate geometry. In our last exercise we were looking at the equation of straight lines and we're looking a bit more at these today, some further equations of lines. So we're going to start with this formula here. It's called the point gradient formula. It's terribly helpful. We'll use it quite a lot over the next 12 to 18 months. The formula is y minus y1 equals m into x minus x1. Excuse me. And we can use it where we have the coordinates of a point, right, an x1 and a y1, and the gradient of a line. Okay, so if I've got the gradient and a point, so not the y-intercept, just some other point, I can use this formula here to generate the equation of the line. That's pretty helpful. So y and x remain the same. x1 and y1 we substitute in for the coordinates of the point, and m, of course, is the gradient. So here's an example. Let's see how it works. I've got the gradient of 2/3, and it passes through the point 4, -1. We're asked to express this in general form. I begin, as always, by substituting into that formula. Okay, so y is -1, x is 4, right? So it's y minus -1 equals m into x minus 4. Now I expand the brackets, and I get y plus 1 equals 2/3 x minus 8/3. I multiply throughout by 3, gives me 3y plus 3 equals 2x minus 8. And finally, to put it in general form, right, all in general form means I'm going to drag the 3y and the 3 over this side here, so that I begin with 2x. So 2x minus 3y minus 11 equals 0. There's our first example using the point gradient formula. Next up, perhaps I have 2 points and I want to know the equation of the line that passes through those. Well, we'll need to find the gradient first, and then I can use either of those 2 points to substitute into my point gradient formula. So what do you know? Here's another example. I want the equation of a line passing through these 2 points, and this time I want the equation expressed in gradient intercept form. That's y equals mx plus b. So first of all, I find the gradient. That's the difference in y. So y2 minus y1 on x2 minus x1. And I find a gradient of 1. After that, I have m equals 1. I'm going to use a point. Now I could use either these coordinates or these ones. I tend to prefer to work without negatives if I can avoid it, so I'm going to go with these ones. And y minus 11 equals 1 into x minus 6. Expand that out and express it in gradient intercept form. Y equals x plus 5. Right. So there we go. We found the gradient and then used the point gradient formula to find the equation of a line. Finally, let's talk about concurrent lines. Concurrent lines all pass through the same point. Now, we could solve these algebraically using simultaneous equations, but it's not necessarily to actually solve all of them simultaneously. Right? What I'm going to do is to find the intersection of 2 lines and then test whether that point lies on the 3rd line. And if it does, well, then all 3 lines must pass through that same point. So simultaneous equations to find the intersection of 2 of the lines, or 2 of the equations, and then substitute to check the 3rd. Here's an example. So I have 3 equations here. I've got to solve 2 of them simultaneously, and I think that this first equation, y equals 2x, is well set up for substitution. I don't particularly like fractions where I can avoid it, so I'm going to substitute this into this. So here we go. There's my 2 equations labelled 1 and 2. I substitute 1 into 2, and I get, instead of writing y here, I'm going to write 2x. So 2x is -3x plus 10. Rearrange that. 5x equals 10x equals 2. Substitute back into any of our equations, but probably that first one. Y equals 4. So we have shown that this line here, y equals 2x, and this line here, y equals -3x plus 10, that they intersect at the point 2, 4. Now I'm going to substitute the coordinates 2, 4 into this equation to see if they satisfy that equation. I'm going to do that by looking at the left-hand side and the right-hand sides independently. So the left-hand side is just y, and y equals 4. So the left-hand side is equal to 4. The right-hand side is half x plus 3, which is half times 2 plus 3. Half times 2, of course, is 1, equals 4, which means that the right-hand side is equal to the left-hand side, which means that, therefore, all of those things together, all three lines are concurrent, and that occurs at the point 2, 4. I can check that graphically. Here are those three equations in Desmos. Y equals 2x is the red line, y equals half x plus 3 is the blue line, and y equals negative 3x plus 10 is the green line. We can see they all intersect at 2, 4. They are concurrent, okay, just as we determined algebraically. So that's it. Let's just recap these things that we looked at today. The point gradient formula. Y minus y1 equals m into x minus x1. Get used to it. We're going to use it a lot. It's pretty handy. It makes things a little bit more efficient, a little bit faster, and as I say, you'll use it a lot. Okay, point gradient formula. The other thing we looked at were concurrent points. Oh, that's the wrong transition. Concurrent points. We're looking for perhaps three lines that all intersect at the same point, and I do that by solving two of the equations simultaneously and then substituting the point of intersection into the remaining equation. Rightio, that's it for coordinate geometry. If you've got any questions, please jot them down, and I will see you during our Teams meeting. Okay, thanks, Year 11. Bye.